All right, we're going to work a practice problem for a projectile that is launched at an angle. So if you read a question and it says that you have something that is launched, kicked, shot, whatever, at some degree, that means that we are dealing with some sort of angled launch. So the way that we're going to give you these questions is to simply tell you what that angle is above the horizon, above the horizontal axis, above the ground. There are a few different ways that we will word that. What I need you to understand is that when you read this angle, that means that you are dealing with a diagonal. All diagonals are composed of a combination of vertical and horizontal motion. I have to have some sort of horizontal piece in order to create my diagonal. I have to have some sort of vertical piece in order to create my diagonal. So if the question were to give you some value for the diagonal and then we give you some value for the vertical, if you needed the horizontal, so this would be the initial velocity, this would serve as the vertical component of the initial velocity. If you needed that horizontal velocity, you would have two sides of a right triangle. You would just do a squared plus b squared equals c squared, where the x side is your a, the y side is your b, and your hypotenuse would be whatever that actual diagonal value is. So you're basically performing Pythagorean theorem, and you are just doing the appropriate algebra to solve for, in this case, you would be solving for A on the original Pythagorean theorem formula. If the question does not give you two of the sides, then you cannot do Pythagorean theorem. So if you do not have enough information to do Pythagorean theorem, then ideally you are given at least one of the sides to go along with the angle, and then you're going to have to do the necessary trig, which is the situation for this question. So here it says, you kick a soccer ball at an angle of 40 degrees above the ground with a velocity of 20 meters per second. So here's the ground, and we are going to kick the soccer ball at an angle of 40 degrees. It says with a velocity of 20 meters per second. The fact that it does not identify this as either a vertical or horizontal tells me that it's neither one of those. This is the velocity along that diagonal line. So my initial velocity is 20 meters per second along the diagonal. The first question asks, what are the vertical and horizontal components of this soccer ball? Now, before we get into the specifics, I want to make sure that everybody understands this is a projectile that's being launched, so it's going to follow a true parabolic path. This question is not asking for displacement. We are not trying to do a right triangle to get a how high or a how far. What we're doing is we are taking the diagonal velocity that it gave me, and we are going to recognize there is a horizontal piece. So that is going to be the horizontal component of that 20 meters per second. How much of the 20 is in the in the horizontal direction? There is a vertical piece, and that is going to represent how much of that initial 20 is in the vertical direction, okay? So for this question, we are using our right triangle. 20 is my hypotenuse. 40 is my known angle, and I am going to have to figure out how to calculate velocity in the horizontal direction and how to calculate velocity in the vertical direction. Now, we reviewed this in the lesson, but I will go ahead and briefly review this here. My horizontal side is the side that is adjacent to my known angle. So this side shares the corner with my known angle. So the adjacent side is going to follow the acronym CA. Cosine equals adjacent over hypotenuse. So cosine theta is equal to the adjacent side, which is my velocity in the x direction, over the hypotenuse. So when I do my algebra, I find that the horizontal velocity is calculated by taking the hypotenuse of my right triangle times the cosine of theta. So I am going to take 20 times the cosine of 40 degrees. And you need to make sure that your calculator is in degrees. When you plug this in your calculator, you get an answer of roughly 15.32. There are more digits in my calculator. I'll just write a few of them down. So on my triangle over here, of the 20, 15.3 blah, blah, blah meters per second is the horizontal speed. In the vertical direction, we are looking at the side that is opposite the known angle. So that's going to be the SO acronym. So this is the sine of theta is equal to the opposite side, which is going to be my velocity in the vertical direction, over my hypotenuse. So once again, I multiply both sides by hypotenuse, and my velocity in the vertical direction is h times the sine of theta, which would be my 20 times the sine of 40 degrees. So when I put this in my calculator, I am going to get something around 12.8. Okay, so this is how I would go about finding those values, because they were not originally given to me and I did not have enough information to do Pythagorean theorem. Guys, after you complete this part, you no longer need to use the trig. You no longer need to use your angle. From here, I am going to simply make my XY chart where X is horizontal, Y is vertical. I'm going to stick with my DVAT template, and I'm going to pause for a moment to review some facts. In the horizontal direction, there is no acceleration. In the vertical direction, we always have gravity. In the horizontal direction, my velocity is constant, so it's just v. In the vertical direction, my velocity changes because gravity is causing it to change. So we are going to designate this for our initial velocity. If I needed, I could add a final velocity farther down the list. Just add it to the line, okay? When we talk about our time, remember it is the total time that is the same for both vertical and horizontal motion. This is the only thing that you can use on both sides, all right? So now that we've already done our trig, we're simply going to take the values that we calculated and we're going to input them. Now, if I can use those lingering decimals, I definitely want to do that. Because this is a multiple step series of questions, what I recommend is that you write down at least a few digits past that decimal point, and that will just help your rounding to come out the same as mine or close to mine at the very end, okay? All right, so question A was really just kind of asking us to do the trig here. Question B should sound and look similar to things that we've already done in previous lessons. So what we're doing in question B is calculating how high the soccer ball went. So we are looking for our displacement in the vertical direction. So now in the vertical direction, they want to know how high, and we have to pause and think about what we know for vertical motion. My projectile at the highest point would be right here. So here is the displacement that we are currently solving for. So I need to recall that at the highest point along the vertical axis, my object has a velocity of 0 at the very top. So I have my XY chart over here to the side. I'm going to rewrite it just to help us stay focused on what information we have for this particular question. So the D is what it is asking me to find. My VI is something around 12.85. My acceleration is gravity. And I know that at the highest point, my velocity is 0. Now this question is asking me to solve for the height. So using my equations, using my list of equations, this is going to fit into VF squared equals VI squared plus 2AD. All right. Now the way that works is if I use my velocity at the top to serve as my final velocity for this calculation. So VF is 0 equals, this is going to be my 12.85 whatever squared plus 2 times negative 9.8 times D. So I'm not going to go through the specifics of the algebra, but when that's all said and done, you are going to calculate the displacement to be roughly 8.4 meters. I'm cutting some corners here, so my sig figs might be slightly off, but you should be about 8.4 meters. And that is the vertical displacement of my object, okay? Now, we have some additional questions that we are being asked here. So the next thing that we're asked to calculate is what is the soccer ball's hang time? So now they want me to calculate how much time it takes for the soccer ball to go up and come back down. They want the total time. So I am now going to have to allow my projectile in the vertical direction. So hang time means total time. So now I have to allow my projectile to go up, pause up here at the top, and then come back down. And it's implied that it returns to its original launch height. So I know my initial velocity on its way up. And conceptually, I should understand that when it returns to the same vertical position, it has the same speed, but now it has a negative direction. So I could say that my initial velocity is 12.855, blah, blah, blah. My acceleration, once again, is gravity. My total time is what I am looking for. And if I'm just kind of copying in the same order that I would be looking at it on my XY chart. Now you may be wondering, why did I not use my displacement? Guys, if you can go back to the original question and use those variables to answer this individual question, that is what we recommend you do. Here's the deal. I absolutely could have used my distance equation and used that to help me find a time, which I could have then turned into a total time. But number one, that's more complex and requires more steps. Number two, what if I goofed on my displacement? Then that means that this answer is also going to be wrong. So whenever possible, go back to the original list of givens and use those variables as your preferred variables for choosing your equation. Okay, so then this list alone is not enough information, but this 12.85 here could serve as the final velocity because the ball is going to go up and then it's going to come back down, and that's what it's asking for. So at the end of its hang time, the final position would be the ground. So I would use this value as my final velocity. Okay, so now I need to pick my equation. So looking at the variables that I have a VI, an A, a VF, and I'm looking for time. So A equals VF minus VI over T. And if you recall the shortcut, these two variables are simply going to swap places. So T equals, my VF would be negative 12.85. My VI, so this is minus, and then I input a positive 12.85. And all of that is going to be over gravity. Again, I'm not reviewing the details of the algebra here, but here's what I would plug in. When I put all of that into my calculator, I come up with an answer that is roughly 2.6 seconds. Okay? Now, the next question wants to know how far away horizontally does the soccer ball land? So now we are being asked for this horizontal displacement. So in the horizontal direction, I'll pick a different shade of blue. So from where it started to where it lands, how far away is that? That is the question. So this wants D in the X direction. So now we are on the horizontal side of our list of givens. So horizontally speaking, D is my unknown. My velocity in the X direction we calculated earlier with our trig is roughly 15.32. And then when we are calculating for our time, or when we're calculating for horizontal, make sure that you are remembering that it must be your total time. So this 2.6 seconds in the previous question represented the total time. So that is this value here as well. This is the only value that is the same on both sides, all right? So I'm going to use my 2.6. Now, if I had the specifics, I would put those lingering decimals. I just don't have those handy. So I'm going to write the 2.6, but please know that when you do this on your own, try to use as many of those decimals as possible, okay? So V equals D over T. So now I'm going to say 15.32 blah, blah, blah is equal to D times 2.6. Remember, we're multiplying both sides by time. So my D is going to come out to be 39.8-ish. So I'm going to round that off to 40 meters. And this is my displacement in the horizontal direction. The next question says, what is the soccer ball's horizontal velocity? That's a conceptual question, guys. That is not a math question. So if we think back to the notes and that picture that we had of our projectile that was going along the parabola, and then we had those velocity vectors in the horizontal direction, all of those arrows were identical. So the horizontal velocity when it reaches the ground is the same as the initial horizontal velocity that we calculated way up here in question A, because velocity on the horizontal axis is constant. So I am simply going to write my Vx rounded for sig fig. So if we originally said it was 15.32 something, this would just be 15 meters per second. The next question says, what is the soccer ball's vertical velocity when it reaches the ground? So we're back to this up and then down motion. And again, assuming that it falls at the same vertical position from which it was launched. So here it says when it reaches the ground, so they're telling us to return to the ground. I am supposed to know that the speeds are the same, but the velocity is going to be in the negative direction. So vertically speaking, this said vertical, vertically speaking, my velocity is going to be the same speed but negative. So we would round this to 13 meters per second.